Okay, in this video we're going to be doing Calc BC Problem Set number 15. The problems in a playlist are in the description below. Let's take a look. Let f of x equal x cosine of x. It is known that f of x has a critical point at x is approximately 0.8603. Since f is continuous and differentiable, we know that f prime of that value must equal 0. So what we want to do is determine by hand / graphical reasoning if f of x has a relative max, min, or neither at that value. So I'm going to need to know the second derivative, I think. Or I'm going to have to do a sign chart, but I don't like my odds of that. So f prime is going to be first. Derivative of the second is negative sine of x, plus second, which is cosine. Derivative of the first is just 1. So that's our first derivative. Now we need to find the second derivative, because there's no way I'm making a sign chart for that thing. All right, so product rule for this first part. First, derivative of negative sine is negative cosine, plus second, which is negative sine. Derivative of first is just 1, and then plus the derivative of cosine, which is negative sine. Okay, so this simplifies to negative x cosine of x minus 2 sine of x. So now the question becomes, can we figure out if this is positive or negative? I think we definitely can, because the value we're given is 0.86, and pi over 2, which is going to be 90 degrees. Pi over 2 is the dividing line for the first quadrant, is 1.507, right? Like pi divided by 2. So 3.14 divided by 2. And because of that, we know that 0.8603 is in the first quadrant, and everything in the first quadrant is positive. And since everything in the first quadrant is positive, that cosine and the sine are both positive in f double prime, and then the negative 0.86 is obviously negative, the negative 2 is obviously negative. Overall, the second derivative is negative. So we can reason this out. It's not like super straightforward, but we can do it. So we know the second derivative is negative, the first derivative is 0. The second derivative test tells us that must be a relative maximum. So there you go. Since f prime is 0, f double prime is less than 0, f has a relative maximum at 0.8603. Not super straightforward, but not terrible. Let's take a look at part B. Evaluate the integral from 0 to 2 of f of x dx by hand. All right, so we're doing a definite integral. I'm going to do an indefinite integral because anytime it's integration by parts, I'm doing an indefinite integral and then going from there. So we need to pick a u and pick a dv. Integration by parts, like pretty common, I guess, on the BC exam. It's not super common, but you're going to see it for sure. So then du is going to be dx. V is the integral of cosine, which is sine. So we're going to get uv, so x sine of x, minus the integral of v du, which is sine of x dx. Integral of negative sine is cosine, so we get x sine of x, and then minus negative, so plus cosine. And then plus c, but we're doing a definite integral, so we know that this integral is just take the antiderivative and use the fundamental theorem. So it's x sine of x plus cosine of x from 0 to 2. When you plug in 2, nothing nice happens. You get 2 sine of 2 plus cosine of 2. Like, what are you supposed to do with that? And then minus, when you plug in 0, almost nothing nice happens, except 0 times anything is 0, and then cosine of 0. So we just get minus the cosine of 0. Cosine of 0 is 1. Make sure you know that. The 2 sine of 2 and the cosine of 2, they don't go anywhere, so that's just what's going to be in our answer. 2 sine of 2 plus cosine of 2, and then minus 1. That's our actual answer to this question. Let's look at part C, which is sort of related. We want to find the 5th degree Maclaurin polynomial, meaning centered at 0, for f of x, which is x cosine of x, and use it to approximate the integral from 0 to 2 of f of x dx. Okay, so start off with cosine. Cosine of x, we know, is all the even powers. So it's going to be to the 0, so 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial. And it keeps going, but we only need 5th degree. And so this is weird because that's 4th degree. But don't forget, it's x times cosine. So f of x is going to be x, approximately x times that polynomial that we wrote. So 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial. Don't be afraid of doing this. People think this is... People want this to be harder than it is, I think. It's you got to at some point come to terms with, like, you can replace a function with a power series and get approximations, sometimes exact answers, but always approximations. So x times that thing is x minus x cubed over 2 factorial plus x to the 5th over 4 factorial. So our actual integral is going to be approximately the integral of the polynomial that we just found for f of x. So we're going to integrate this. This is just reversing the power rule. Possibly part of why they're called power series. So 1/2 x squared, and then you do plus 1, so minus, so x to the 4th, 4, and then there's still 2 factorial. And then plus 1 will give us x to the 6th, 1/6, and then there's still a 4 factorial. And then we're going from 0 to 2. When you plug in 2, I don't know, it's just like weird. You get 2 squared over 2 is 2. And you get 2 to the 4th, which is 16 over 4, which is 4, divided by 2, which is 2, so minus 2. And then you get 2 to the 6th. And then you have 6 times 4 factorial. So 6 times 4 factorial is going to be 2 times 3, and then 2 squared, 3, 2, 1. So we can write this in factored form, which I think is almost always better. So 2 to the 4th, 3 squared, and then a 1. 2 to the 6th over 2 to the 4th is 2 squared. 2 squared over 3 squared is 4 over 9. So that's what the entire first part simplifies to. We still have to plug in 0, but plugging in 0 doesn't do anything. Well, it zeroes it out, so it does something. So we end up with just 4 over 9. So that's our approximation. And we did it by hand, and that wasn't really that bad. The next question says, use your calculator to evaluate and compare the numerical values of your two previous answers. We actually have like 3 answers. One of them is obviously the right answer. So I just did the approximation. So I approximated this, and then I just did like 4/9 is 0.4 repeating. It's pretty close, and we only used 3 terms. Like we could have used 10 terms, and it would be a much better approximation. All right, let's take a look at the next one. Determine all values of p such that the sum from 1 to infinity 1 over n to the 6p squared minus p minus 4 converges. Okay, so to do this, we need to remember that 1 over n to the p is a p series. That'll converge anytime the exponent is greater than 1. So we need that exponent, which is 6p squared minus p minus 4, to be greater than 1. That's what we're trying to solve. This is now just like an algebra 1 problem, maybe algebra 2, probably algebra 1. Move everything to one side. Now factor, which is an annoying factor because if like my instinct is always to go 2p and 3p, because I'm like firmly convinced it's almost never just like, if it's a composite number, I think it is never like the number in 1. In this case, it actually is though. So we can go plus 5 minus 1, and then we can do a sign chart. This is a quadratic that opens up, right? So you know it's going to go plus minus plus. Or test values, up to you, whichever you want to do. Like this, and then we can just write it. So this thing is definitely going to converge as long as p is less than -5/6 or greater than 1. Those are the intervals on which you will get a convergent p series out of this thing. All right, so that's the entire problem set. I hope this was helpful, and good luck.